The question is, could you do an example on adding 3D forces by the algebraic method? This is the problem that I have selected here. The problem basically involves the use of the projection method. There are three forces, F1, F2 and F3 acting at the same point, and we have placed a three-dimensional Cartesian coordinate system at that point. In other words, the origin of this Cartesian coordinate system coincides with the point where the forces are acting. F1 has a magnitude of 80 kilonewton, F2 has a magnitude of 20 kilonewton, and F3 has a magnitude of 90 kilonewton. For F1, these two projection angles are given. For F2, the direction is defined in terms of these ratios, 3 vertical to 4 horizontal to 5 along the hypotenuse. The direction of F3 is given in terms of these two projection angles. The question is to find the resultant of the three forces F1, F2 and F3. So let's work on this starting with force F1. We note that if this is 30 degrees, this is also 30 degrees, and therefore this length is 80 cosine 30, which happens to be the y component of the force. So that goes in here in the middle with the unit vector j. This side here from O to D will be 80 sine 30, right? So we're going to take that and resolve that along the x and z direction. So you see 80 sine 30 with both the first component and the third component. Now looking at this right triangle ODG, we see that OD cosine 20 is the x component of the force. So you see cosine 20 over here with the x component of the force. And the sine 20 is going to give me this distance, but this distance happens to be in the negative z direction. And therefore, we have a negative sign in front of the z component, and we multiply this distance, which is OD, by sine 20. Simplifying it using the calculator, we have this. Now considering the force F2, first we note that this line is parallel to the x-axis and this line is parallel to the y-axis, right? So what does that mean? That means the force F2 lies on the xy plane. Its z component is 0. So you see 0 here that goes with the unit vector k. All we have to do is to find the x and y components. So this is like doing a two-dimensional problem. Remember how we deal with ratios like this, right? The horizontal component, the component along the x-axis, is simply 20 multiplied by 4 over 5, right? So that's what I have here. But we also note that the horizontal component is going to be in the negative x direction. Therefore, we put a negative sign in front of that. The y component, which is the component in the vertical direction in this picture, is simply 20 multiplied by 3 over 5. So that's what I have over here, 20 multiplied by 3 over 5. But there the arrow is still in the positive y direction. So we have a positive sign in front of that. Simplifying this using the calculator, we have this. Here is the component form of F3. First, we consider the right triangle OEC and recognize that this angle is 45 degrees and this is the hypotenuse, which is 90 kilonewton. 90 sine 45 gives you this distance from E to C, which is the negative part of the y component of the force. So that's what I have over here. Minus 90 sine 45 goes with the unit vector j. 90 cosine 45 gives me this distance from O to E. We're going to take that and resolve that along the z-axis and the x-axis, right? So you see 90 cosine 45 appears both on the x component and the z component. Now we consider this right triangle OFE and we recognize that this angle is 25 degrees, right? And therefore OE sine 25 gives me the x component. So we have a sine 25 over here, and OE cosine 25 gives me the z component. So we have the cosine 25 over here. we know that while the y component is negative, the x component and the z component both are positive. After simplifying, we get this. Here's a summary of what we found so far. This is our F1, this is our F2, this is our F3. Let's go ahead and find the resultant of the three forces. Here is the resultant F. The x component of the resultant is the sum of the x components of the three forces, and the y component of F is the sum of the y components of the three forces, and so on, right? The magnitude of F is readily found by this equation, so you get a value of 67.81 kilonewton for that. The direction angles of the resultant F are found by these equations. Here is the geometrical representation of the resultant F. The magnitude is 67.81 kilonewton, and it makes an angle of 44.3 degrees with the x-axis, 74.9 degrees with the y-axis, and 49.5 degrees with the z-axis.